Alright, so last class what we did was we went through and did basic shapes using not the drafting tools, but just using the using your hand and a pencil to do your best to create straight lines and shapes and things of that nature. Today we're going to be sketching as well, but instead of doing it freehand, we're going to be using the graph paper that's in front of you. You won't be doing any curves today, but there are 3 different assignments that we're going to take a look at before we finish with graph sketching, which are the next 3 in your assignment book. But to start off with, like I said, make sure that you have oriented your paper so that the hole punch is to the top. And then at the very bottom, in the bottom row, put your first initial and last name and your kit number. The assignment is Lab 3. And make sure that you have P1 drafting in this corner. Okay. So anytime that you don't have a piece of paper that has a title block on it already, you need to make sure that you fill out the bottom edge of it in this manner. Most of the time you will have the title block though, because I do hand that out to you. Okay. So what we're going to look at here is the next assignment page in your notebook. If you're counting pages from the front, it should be the 36th page. It is labeled Lab 03, and looks like this one right here. There's a couple of different things here that we're going to take a look at. First off is that this is your first exposure, at least in this class, to what's called a 3-view drawing. This will compose the bulk of the work that we do in the class, doing 3D-view drawings, and this is one of the most simple that you'll see, and is usually the first, some version of this will be the first assignment that you do for each type of drawing. So for example, this will be your first graphing sketch. It'll be the first 3-view drawing that you do. It'll be the first isometric drawing that you do. And it'll also be the first sheet that you dimension. So it's really important to hold on to this, or not this piece of paper, but to the experience that you get thinking about how this shape fits together, because it really serves as the basis for a bunch of the different assignments that you're going to do. Okay, so a couple of things about 3-view drawings that we want to look at first. First off being that while there are 3, or in this particular case there are 4 different views of this same shape on the page, they all represent the same physical object. So if I was to take a physical object and hold it in my hand, which this would probably be something that would be very good for me to actually create for you to hold on to and look at, but we have a certain way that the views are presented. So here is, so the very top one that we have, the one that has 1.5 inches down the side and then a mark that says 0.50, that's going to be your top view. If we're looking at the sorry, I keep forgetting you can't see where my hand's going. If you're looking at the isometric view, that's what this view over here is called. Then the top view would be these lightest gray sections. Even though this one's down below, if you are looking directly down onto this object, that would be what you would see. The front view, in this particular case, is identical to the top view. It's just turned over 180 degrees, so it's completely flipped. Is the same view, but on the isometric view over here, it's the darkest gray section. And then you have the right-hand side view over here that is the kind of intermediate gray that shows up on your sheet. So if you think about how everything fits together when you're drawing it, it'll make it a lot easier when it actually comes time to do the isometric view. That starts somewhere around lab 20, I think, that we start looking at isometric views. So you don't have to worry about it for the time being, other than that you need to be aware almost every drawing that has a 3-view drawing will have the isometric view in the corner, because I want you to start thinking about how everything fits together. The other thing that we need to pay attention to when we're doing 3-view drawings is that they are lined up properly. So if we look at what's on the screen right here, or on your paper in the book in front of you, you'll see that the top view has the most detail attributed to it. So it tells us how wide the square is and how tall the object, or how deep the object is, how wide the thing is overall. If we look down at the front view, which is directly below it, it only has 2 dimensions attributed to it. And the reason for that is that everything we need to know about the width of this object is being told to us on the top view. So we have the 1.5 inches over here that directly attributes to this square right here. You have the 2 inches, which directly attributes to this L shape right here. And then you have the 1.5 inches right here, which is attributing to the width of this kind of step piece. Because we know that that's 1.5 inches and that is 1.5 inches, then we can determine that this line here, the top of the L, is also 1/2 inch. Now the hardest one to get your mind around sometimes is the right side view. On this specific one, there are no dimensions at all on it, because you don't need them. So first off, everything about the height of the right side view is being told to you by the front view. Everything about the width of the right side view is being told by the top view. So if you think about how these would fit together, if this was a real 3-dimensional shape, then any dimension that is the height of the top view gets transitioned to become the width of the right side view. That's probably really confusing to you right now if you've never thought about how shapes fit together before. And that's basically what we're going to spend the first several assignments doing, is starting to think about how things fit together and how to take information from one view and attribute it to another. That is why one of the biggest things I harp on, and that you will lose 10 points on an assignment right off the top, or 10% on an assignment right off the top, is if your views are not aligned. So if you look at this, if I were to take a ruler, put it on this screen, and run it down from this corner right here where my mouse is, these would line up perfectly. Same with this one on the bottom, would line up perfectly with this over here. The same goes for all of the horizontal lines and all of the vertical lines between the front view and the top view. Does that make sense? Okay, well, we're going to put it into practice in a few minutes and see if there's any place that we need to improve upon my explanation. Because I guarantee you there's always room to improve upon my explanations. So let's take a look at the paper in front of you. What we're going to do is we're going to start with the front view. And that's usually the best place to start when you're doing any drawing, because once you have the front view done, then you've got 2 of the dimensions of your side view, or 1 of the dimensions of your side view done, and 1 of the dimensions of your top view done. So what we're going to do to find a place to start, on the regular title blocks without the grid paper, you are given center points here, 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 and here for 3-view drawings. This corner up here would be for an isometric view, but like I said, we aren't doing that right now. And the point of this is so that each view would be centered in its quadrant. We're not as worried about that with the graph paper. Oh, sorry. I apologize. I forgot that I didn't have that on the screen. So here's what I was talking about. You have the 4 corners, or the 4 plus shapes on the regular graph paper that we use, or the regular title block paper that we use. And that one there is for the isometric view. That one would be the center of your top view, the center of your front view, and the center of your right side view. Okay. We're going to use the same placements for this on the graph paper, but we are not going to worry as much about having them centered in their quadrants of the paper. So like I said, we're going to start with the front view. And to find its starting place, from the box that contains your title block, you're going to come up 4 and you're going to come over 4 from the edge of the page, and you're going to make a dot. Now this is 1/4 inch graph paper, which means that if I were to get a ruler out, as long as the copier didn't change the scale of the paper, then 4 of these boxes should equal 1 inch. Okay. So just like when we were drawing with paper, drawing free-handed, we're going to start off by finding our distances and then putting dots in to be the start and beginning point of our line. So if we're starting with the front view, I'm going to go ahead and go with the easiest dimension to use, the one that was given to us most blatantly on here, which is the 1/2 inch and a half height. So from the dot that I asked you to make, you need to go up how many boxes? 6 boxes, right? And then make a mark there, and then connect the 2 dots with a line. Trying to stay as on the grid line as possible. Now the top view does not give us an overall size, but it does give us enough information to figure it out. It says it's 1.5 inches wide to that cutout for the L shape, and then another 2 inches to the other end. So that means that our entire shape, the box that the front view would fit in, is 1.5 inches tall by 3.5 inches wide, right? Ordinarily, when you are drafting with the drafting tools, that would be the first thing that I have you do, is you create a box that your shape fits in. Because our measurements are being taken by the graph paper itself in this case, I'm not going to have you do the full box because that would just lead to some unnecessary erasing. What we are going to do, though, is continue to use the dots like I said. So, how far over do I need to go from this point right here to make the next line on my front view? Who can tell me? So you have to look at the paper the paper in your book. What's it tell us? Three and a half inches would be if I was coming all the way over to this spot out here in space.
Wait, I'm
So we're trying to figure out how long this line is right here.
Oh, it'd be 2 inches.
2 inches, exactly. You know that a couple of ways because we know the whole shape is the same length, and this one up here tells us that to this first line right here would be 1.5 inches, and we know that it's 1.5 inches on this side of the top view. That means that it would be 2 inches to get to this end right here. So that's 8 boxes, right? Alright, so we have a couple of choices from here. What would you do next? We could either... There's a couple things we can draw next. Ideas?
Go
Down how far?
1.5 inches.
From which point? From right here, or...
The point we just, like, from.
Okay. So 1.5 inches down would put us all the way at the bottom of the shape. But do we want to be there, or do we want to be somewhere else?
Just an inch.
Just an inch, right. So you're going to come down an inch, 4 boxes. Okay. Anybody else give me an idea of where to go next? An inch and a half, which direction? To the right. Yes. So, well, keep forgetting I had to switch back and forth. So from this point right here, you're going to come an inch and a half to the right, like she said. 2, 4, 6. Okay. Come down 1/2 of an inch would be the next one. And that puts us on a line with the first point we started from. So the easiest thing to do here would be just connect them, because there's, if we look at our drawing, there's no other interesting features about the bottom line other than it is a straight line. Alright, so we have one last thing to do to finish the front view here. Huh?
Dimensions.
So we aren't going to worry about dimensions for right now, but we are missing a line still. So what can you tell me about that line that we're missing? It's a
It's a 1/2 inch from. Like the top right.
So a 1/2 inch, so right there, basically? Okay. So you're right. So it's one solid line going straight down, 1/2 of an inch from this kind of upper mid corner. I wouldn't say it's the upper right hand corner, because technically that's this one right here. But from right here, you're going to come back 1/2 of an inch and connect a line straight down. Alright, so now you can make a choice. Do we do the right side view next, or do we do the top view next? So it would be possible to do the top or the right side view next, but realistically I would do, like you said, I would do the top view next, because it has more information, and it also tells us how wide our right side view is going to be, and this will give us some thought about how to put this right side view together without actually without having yet done it. But that's not the one I wanted. There we go. Okay, so usually when you aren't worried about putting a shape in the center of a quadrant, you want to have about an inch between any views, unless there looks like it needs to be an excessive amount of dimensioning to happen. This is not one of those times. So you're going to come from this corner right here. You're going to go up 4 boxes or 1 inch and make a dot. And that dot is going to be the lower left-hand corner of your top view. But what do you notice about said top view?
We don't have a point right there.
Right, you don't have a point right there. So this will definitely be something that you'll end up erasing, but it is a good reference point, because that is the corner where this line here starts. It's also the corner that has this line resting on it. So essentially, to find the starting points for the shape itself, we need to mark out the box that isn't there. So if the whole shape is 1.5 inches tall, and the part of it that we need is at the top and 1/2 of an inch, we have to come up another inch and make a mark, and then go ahead and draw that 1/2 inch line. Now I'm going to do the same, but I'm going to basically, I'm going to go ahead and do the bottom line of the top view. But I don't even need to count over how many boxes that I need to go. I'm just going to look at this line that we drew here and find out where it intersects the line that our first dot of the top view is on, and put a mark there. I'm going to do the same thing with this line over here. And with this corner right here. Okay. Now, even though I am going to draw over this dot that represents this corner, I don't need, I won't need to, or I'll be able to see it still. And that is where this line is on the top view. Actually, at this point, because I already have this corner up here, I don't need to measure anything else. I can just find out where lines intersect and finish my drawings that way. So if I look at this top corner up here, if I wanted to find this one really quick, what I would do is find this dot here and figure out where it would intersect with a line that that dot sits on. In this case is right here. I would do the same thing to find this interior corner right here. And with these dots, I have all of the information I need to finish this. So like I told you, I was going to start with the bottom line, or do the bottom line here second. And then literally, I'm just playing a game of connect the dots. It's not too crazy, right? The thing that is hard to remember when we get the drafting tools out is that almost everything is literally just this simple. The only difference is you don't have the grid lines to help you out. And I think that's probably the biggest mental hurdle that people have issues with when it comes to manual drafting, is that everything is there for you as long as you get that first corner right. You just have to use that as a basis to get everything else put together. And like I said, we go over this quite a bit, and it's not my purpose or my job to make this harder for you. I'm trying to help you understand how things go together. So if I was to do my right side view next, which is what I'm going to do, I'm going to come over an inch again, just like we did to get up to the corner for the top view. I'm going to go ahead and put the dots in that represent my horizontal lines on the front view. So, got my starting corner, the dot that represents the top of this step shape right here, and a dot that represents the top of the shape itself that lines up with this one. Now all of your horizontal measurements on the right side view come from the height of your top view. So if I was to pick this up and turn it, let me do this. Maybe this. Two, 4, 6. Alright, so I don't want you to draw this, but I'm hoping it'll help you understand how this fits together. So this is my top view, right? Correct, I mean? This is also my top view, but I turned it 90 degrees this way to help you see how this lines up. So if we take this corner, which when it's been rotated has become this corner, put it right there and right there. So we have the square that my shape fits in, that the right side view fits in. We also know from the drawing that we're working from that we have a solid line going across right here, which represents the side view, or all that you would see of the side view, from this light gray square on the real shape. And that's essentially the whole drawing except for one thing. Now, if I were to hand you this and tell you this is the top view, this is the front view, you almost don't even need the right side view to be able to know what this shape looks like. But that's not always the case. And sometimes there are things that you have to know about an object when you can't see all of its features. So, if you were to look at this box here that I've got I don't know why I'm holding it up. If you were to look at this box that's holding my calipers, and we'll just pretend like it's a perfect rectangle that you can't see the hinges here. You would see that this box is about 3 inches tall, probably about 7 inches long. If I were to turn it like this, we could see how tall it is, about 3/4 of an inch tall. But what we can't see from these two views, the top, the front, and the side, is that there's a whole bunch of detail on the underside. There, can you see that? There's a whole bunch of detail on the underside that represents the cutouts that the calipers fit into inside of this box. And if the top and the front and the right hand side are the only views that you can draw, it's not the case always, but let's just say for this example that it is, those are the only three that you can draw, but you still need to get this information across, then we would draw what are called hidden lines. Hidden lines are blue. They're drawn in blue. They're a dashed line that has a certain spacing in them. The sheet in front of you is probably in black and white. It's going to look like a slightly lighter gray than the black of the lines around them. They are the reason that you have blue lead in your pencil boxes. And we're going to draw this hidden line, but I'm not going to ask you to pull blue out of your box. We'll do that at some point in the future. But for this one, we're going to go ahead and put our hidden line in. So if we look up here at our rotated top view, you'll see that this line right here is this wall, basically, if you're looking at the isometric view, or this one on the front view. But you would not be able to see it on your right side view because you're looking at this right here. Your right side view consists of this square, or this bigger rectangle and the smaller rectangle. So it would be a hidden line. So just do your best to make an even kind of dash going through your whole shape. And that's going to be 1/2 of an inch from the right hand side of your right view. Okay. Alright, so essentially what's going to happen now that we've done this one together, you should have 2 to 3 sheets of the graph paper. I want you to turn the page in your book, and we're going to take a look at the second one. Let's see here. Oh, that's a line. We are going to make a couple of slight changes that I forgot to do before I printed the manual. So if we take a look at our front view here, right now it says that the height of it is 0.38 and 0.63. Those are not impossible for you to measure, but since we're using 1/4 inch graph paper, I'm not going to have you divide the graphs. So what we're going to do here is we're going to change that 0.38, and we're going to make that 1/2, so 0.5. And this 0.63, we're going to make 0.75, so 3/4. That's not going to change our quarter or our 1/2 inch measurement. No, not our 1/2 inch. Our 1/4 inch measurement over here on the right side view. Everything else about this should be easily done on graph paper. So, you're going to do the same thing here. You're going to start off by putting your title block on the bottom. This one will be Lab 4, P1 drafting. From that title block line, you'll come up 1 inch and over 1 inch from the left-hand side. And go ahead and get started with this one. I will walk around and help you out if you need help. We'll take a look at the other one. If you have any questions, just let me know.